All right, howdy, hey. Um, this is, I believe, the fourth episode. I'm just kidding. We're just gonna go over what we've been doing for the past 3 days or so, which is graphing sine and cosine functions and their phase shifts, and what we went over today, graphs of other trigonometric functions, mainly tangent. So let's see, where do I want to start with this? We'll go ahead and start off with the general form of a sine or cosine equation. That is going to be y is equal to a sine um, times bx minus c. Um, and sometimes you'll see plus or minus d. And then our other function is just going to be the same, except it is going to be a cosine bx minus c plus or minus d. So with that in mind, um, I'll just write this up here. Y is equal to a, go ahead and do sine for now, bx minus c plus or minus d. Our a here is going to equal our amplitude. B is going to equal our period. And the formula to find your period is going to be, oops, 2 pi over b. Let's see. C is your horizontal shift. And then D is going to be equal to your vertical shift. Oh, so now that we know that, we're just going to hop straight into the first example question that we were provided, um, which is going to be y is equal to negative 3.4 sine 5x minus 7. We already know that our amplitude is going to equal 3.4. Amplitude, I forgot to say, amplitude is the absolute value. Let me write it this way. Amplitude is equal to the absolute value of A. So if it's negative, its absolute value of a negative is going to be positive. So that's why our amplitude is 3.4. Now we want to get B by itself, so we're just going to take 5 out of this, meaning we're going to divide it out, meaning it's going to be 7 over 5. That goes out here. So our period is going to be equal to 2 pi over 5. Um, our phase shift, or our horizontal shift, that was horrible. There we go. Is going to equal negative, or is going to equal 7 over 5 to the right. And then we aren't going to have a vertical shift because there is no plus or minus here. And that's it for that first problem. For our second problem, we have y is equal to negative 1 over 5, negative 1 over 5 sine multiplied by pi over 2 x plus 2 pi over 3 plus 1. We know that our amplitude is just going to be equal to 1 over 5. Our period is going to equal pi over 2. Nope, 2 pi over pi over 2, which is just going to equal 2 pi over 1 multiplied by 2 over pi. Pi's cancel out, leaving you with just 4 over 1, or just 4. Our phase shift is going to equal, um, again, since we're dividing this out, this is going to be pi over 2, because this is all the way out here now. Our phase shift is going to be 2 pi over 3 multiplied by 2 over pi. This is just solving a complex fraction. Move this out from under it, flip it, and you get this. So 2 pi over 3 times 2 over pi, those are going to cancel out, um, and you are left with 4 over 3. And that's as much that you can do with it. Just circle these. Um, Now for our vertical shift. Vertical shift is just equal to 1 up. And because this is positive to the left. All right, that was example 2. Sine ones. Now we can go ahead and go into graphs. And I'll just do one. I'll just do. I'll do one of the simple ones and then one of the harder ones. So for our first example, we will have y is equal to 4 sine x. So we have our amplitude, which is equal to 4, and our period is just going to equal 2 pi, because the number that's supposed to be here is going to be 1, because, well, there's nothing in front of the x. Our graph, if I can draw this well, is going to be something like this. We're going to have 2 pi down here. Somewhere in the middle here, we're going to have pi. Somewhere around right here, we're going to have 3 pi over 2. And then somewhere over here, we're going to have pi over 2. If we put down our x's, and then under that, sine x, we can create a small little table like this, where we are going to go 0, pi over 2, pi, 3 pi over 2, and 2 pi. I probably did that way off. Yeah, that'll do. Um, those are our x's. So sine of x, or sine of 0, um, is just going to be 0. And then sine of pi over 2, which is about 90 degrees, it is 90 degrees, is just going to be 1. Then it's going to be 0, -1, then back up to 0. Um, However, since our amplitude is 4, this is going to be changed 4, and this is going to be changed to -4. So -4, +4, 0. We are starting at 0. So first we're going to go up, then down, intercepting at pi, and then down, hitting 4 at 3 pi over 2, and then going up and stopping at 2. That is full, or that is one full period. All right. Now for one of the tougher ones, let's see. We'll go ahead and do, um, go ahead and do the second tough one. Y is equal to 3 sine pi x. Um, our amplitude is going to equal 3, and then our period, I'm just going to write p, is going to equal 2, because it is 2 pi over pi. Those cancel out, gives you 2. So we're just going to write our chart first. We have um, x and sine x. Our first part, we're just going to do 0 pi over 2, pi, 3 pi over 2, and then 2 pi. Sine of 0 is just going to be 0, then 1, then 0, then -1, then 0. Now we're going to do 3 sine x, which is just going to be 0, 3, 0, -3, 0. Same thing that we did on the last graph. However, now we need to convert all this into uh, this measure here. So we're just going to take 0 divided by 2. Wait, nope. We're just going to divide it by pi, since we have this pi up here. So 0 divided by pi is just going to equal 0. Pi over 2 divided by pi is just going to equal 1 over 2. Pi divided by pi is just going to equal 1. 3 pi over 2 is just going to equal 3 over 2. And then 2 pi divided by pi is just going to equal 2. Now that we have that, we can go ahead and draw our graph. Go ahead and draw our dotted line up here, dotted line down here. It is going to -3 and +3. We can see where our x's are. So I like to put my first one here, which is going to be 2. Go to the middle, that's going to be 1. Go to the middle of this one, it's going to be 1/2. And then go to the middle of this one, it's going to be 3/2. And there are our intercepts. Our first point here at 1/2 is going to be 3. So we're going to go up, place a point here. And also this is going to start at 0. My bad. Next point is going to be 1/2, 3. Our next point is going to be 0, 1, or 1, 0. Then our next point is going to be -3, or 3/2, -3. So down here. And then our next point is just going to be on this 2 right here. And that is 1 full period. Our graph is going to go up, and then down, and then back up. Sorry for the shaky line, that's all you're going to get. And then don't forget to draw your arrows, because those are very important. I forgot to draw them on the last one, but whatever, now you know. I'm going to go ahead and do one more with a cosine graph. That way you get an idea of what we're doing with those. I'll go ahead and take one of the easier ones. We have or y is equal to -2 cosine x. Our amplitude is going to equal 2. Remember, absolute value. And then our period, which I'm just going to, again, write p, is going to equal 2 pi, because there is a 1 in front of this x, and 2 pi over 1 is just going to equal 2 pi. Anything divided by 1 is just going to be itself. So we are going to draw our graph. Dotted line on the top, and then another dotted line on the bottom. 2 pi, pi, pi over 2, 3 pi over 2. This is going to be 2. This is going to be -2. This is our 0. And then for now, we will go ahead and draw our chart. So we'll have our x and cosine x. When x is equal to 0, cosine is going to equal 1. Cosine is equal to pi over 2. It is going to equal 0. And then when it's pi, it's going to be -1. And then it's going to be 3 pi over 2, which is going to bring it back up to 0. And then 2 pi is going to be 1. Okay. Now we are going to do our -2 cosine x. So 1 times -2 is going to be -2. This is just going to equal 0. -1 times -2 is +2. 0 times whatever, 0. And then back down to -2. If we plot these points at 0, we're going to be at -2. Or yeah, at 0 we're going to be equal to -2. At pi over 2, we are going to be at 0, and then at pi we're going to be at 2, and then at 3 pi over 2 we're going to be back down at 0, and then at 2 pi we're going to be down at -2. And then we're just going to draw our graph from there. And that is it for cosine and sine graphs.